Let's talk now about this number e, lowercase e. Now, you know this number here, right? This number here, pi, which is about what? 3.14159, dot, 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 goes on forever. Right, this number shows up when you're working with a lot of applications that deal with, say, geometric figures and curves, circles and such. Well, a number that shows up a lot in real-life applications is this number, and we're just going to call it E. It's this number here. It's 2.71818 dot, dot, dot. It's irrational, goes on forever. So we give it this name right here, lowercase e. It's after the mathematician Leonard Euler. And we just represent this number here with the letter E because this number here shows up so often when we're modeling natural processes. Now, in section 6.1 of the book, you can get an idea of where this E comes from as far as computations. But for this part right here, we're just going to say that E is this number right here. So now, let's take a look at this example right here. How about if we have this function right here? F of x equals, say, 10e to the 0.5x. What do you think? Growth function, decay function? Well, I know what my start value is here, right? I'm going to start with 10 units of output. And look at this. This is 50% growth rate. And what about this number right here, that base? Well, the base is E. E is 2.718, right? This is close to 3. This is bigger than 1. So what I'm thinking is I've got a number bigger than 1, so I'm thinking growth. And then I look at this growth rate is positive. So I'm thinking, here's what I'm thinking. I'm thinking positive growth, all right, that's growth. So what I'm looking at here is a growth function. And this problem number 2, growth or decay, what do you think? Well, there's that multiplier anyway, the multiplier of the base, so I know that's my start value. I start with that much. How much is that? If I change it to a percent, it's what? 7.5% of something? Okay, or 0.075 units. Now look at the base. The base is E. It's bigger than 1. But what about the growth rate? The growth rate is negative, right? It's negative 7.5%. So the growth rate is negative, and this is growth. So here's what I'm thinking. I'm thinking negative growth, right? I do it this way. I look at that first and then this. Negative growth. Well, negative growth, well, that's decay. So this, what I'm looking at here, is a decay function. Now here's an application where this might show up. This is in compounding interest. In fact, it's compounding interest continually. So not just you compound annually or quarterly or daily, but you compound continuously. So this will give you the amount of money, A for amount, after T years, if you invest that principal at that interest rate for T number of years. So suppose we had this one. What if we have this function here? 10,000. Right, now that's our start value, right? So you start at $10,000, and then you have E to the, what if we did this? 0.08T. So what does it tell you? The start value is 10,000, so you start with $10,000. Okay, so we would start right here with $10,000. And then what do we have? Well, look at this over here. This is E, it's bigger than 1, so I'm thinking growth. This growth rate is positive, so I'm thinking positive growth. Okay, so I'm thinking, here's what I'm thinking. Positive growth. And what is positive growth? That's growth. So what's going on here? You start with $10,000, and then it's growing at the rate of what? Well, that's 8%. All right, so it's growing at 8%. And that 8% is compounded continuously. So it's continuous compounding. This is not compounded annually or quarterly or daily. It's compounded continuously. So start with $10,000 and you're growing at 8% compounded continuously. So what would this be here? What if we put in, say, 5? What we're asking is this. How much money would we have after 5 years if we start with $10,000, e to the negative 0.08 times 5, and we compound continuously. Well, my calculator says that we will have 14918 point, I'll round up, 25. So if we start with $10,000 and compound continuously at 8%, after 5 years, we're going to have almost $15,000. So it's grown almost by what, 50%? Half of 10,000 is 5,000. So we're right close to 15,000 here. Now here's how I did that. On my calculator, I put in this. I got a TI-84. I put in 10,000, and then I pressed, there's a key on your calculator, and mine says this, LN, natural log, and then right above it, it says e to the x. So I had to press second to get this. So I put in 10,000, I press second, natural log, and then that gave me this. Then I put in 0.08 times 5, and the 14,918 came out.